today we want to look at logarithm. Just like indices, because logarithm is closely related to indices. In fact, in so many texts, you see them treated together, indices and logarithm. So logarithm can be defined as a power to which a base is raised. Thus, if from our indices now, if y is equal to a raised to power n, then this implies that our n, which is the exponent here, is the logarithm of y to base a. That is how closely related indices and logarithms are. Now, for example, now, if you have 3 raised to power 2, we all know that that one will give us 9. This will imply that 2 is equals to log 9 to base 3. Just to establish the relationship between indices and logarithm. Same way, we have 10 raised to power 2 equals to 100. This implies also to 2 equals to log 100 base 10. And more generally, if we have 3 raised to power 3 equals to r now, this implies that 3 here, which is the exponent, is equals to the log of r to base p. Now, as we have in the case of indices, we have rules guiding indices. We also have rules guiding logarithms. That gives us the laws of logarithm. Let a be equals to a raised to power n. This implies that our n is equals to log a, capital A, this small a. You know, this exactly is just, we are picking this directly from the definition of logarithm. If you look at this, y equals to a raised to power n, we are picking that one directly. The same way, we are given, we want to let b be equals to a raised to power n, just like we have in the case of indices, we are still making use of the relationship between logarithm and indices here. This implies that our n is equals to log b base a. Now, the first law now is that when we have multiplication, like in the case of indices, when you have a raised to power n multiplied by a raised to power n, you know, in that case we have a raised to power n plus n. We want to relate that one directly to logarithm here. So if we have log a multiplying b, we have, that means that will give us n plus n, log a plus log b. Since ab will give us a by this, which will give us a raised to power n plus n. Same way with, if we have division, that will be minus, like we have in the case of indices, since we have a over b giving us a raised to power n minus n. The same for the third law. We have, if we have a raised to power n now, log of that, we have mn equals to n log a base a. That implies that this power will become a number on its own, multiplying the whole logarithm of a to the base of a. Now, you want to take other transformational law. These are the fundamental laws of indices. We also have some transformational laws, such as the power of 0, the power of 1, logarithm of 1, and so on. I want to take that one now as number 4 and number 4, 5, and 6. So number 4 now, a raised to power 0 equals to 1. Therefore, the logarithm of 1 to base a will give us 0. Just still relating to the definition. And 5 now, if we have the log of, since a raised to power 1 is equals to a. Therefore, from our definition, if we have log a base a, this will be equals to 1. 1 here will be equals to log a base a, like we have it in the definition. And now, we also have law number 6, which is the change of base. If we have log a base b, this can be equals to log a base b over log b base a. Or this is also equals to 1 all over log b base a. And we call this one the change of base. Now, we now want to see how we can apply all these laws, using them to solve some questions. We want to take some examples to establish all these laws now. Examples. 1. Simplify the following. Let's look at this. The first one here, which is log 8 base 4 plus log 2 base 4. Because we have 4 as their common base, we can perform operations. This 8 here, we can reduce it and see how we can factor the 2 together. Now, if we have log this one, because their bases are the same, we can just multiply this. Since the first log tells us that if we have log a, b, is the same thing as log a plus log b. Therefore, log 8 plus log 2 now of common basis 4 will give us log 8 times 2 base 4. And this one will give us log 16 base 4. Don't forget, our 16 can be written as log 4 raised to the power 2 base 4. And therefore, this will give us, we can equally rewrite this guy here as 2 log 4 base 4 from the third law that we have stated earlier, which is log a raised to the power n. This one gives us base a, this one gives us n log a base a. So we are using that one to transform this. Now, this guy here will give us 2. Why? Because log of a base is equal to 1. Like we stated, that if we have log a base a, this will give us 1. From the initial part that we say, since a is equal to a raised to the power 1, then we can take the log of, we can say our power here, the exponent 1 is equal to the log of a base a. So, therefore, this will give us 1. The same way, we can take the other example. I think I have to remove this. We can put them down. We can put them down in our notes so that we can make reference to them appropriately. The same way we look at this, the same way we take this. Log root a base a now plus log a squared base a, because we have common base also we can multiply. But don't forget, this square root here, we can rewrite that as log a, we can put it in its initial form. As since the square root means this one, and we have this one log a squared base a. Don't forget, from the log we just used down, we can also add 1 over 2 log a base a. Because of this power, it can come here as a coefficient to the whole log, plus, same way to this guy, log a base a. And since this is 1 and this is 1, that implies we are left with 1 over 2 plus 2. This one will give us 2 by 2, 4 plus 1, that will be 5 over 2 minus. Now, we want to take this b, the solution, the solutions. So b now, we have log 14 base 2 minus log 7 base 2, same application. This is the same thing as log 14 over 7 base 2. I hope you all agree with that. And this will give us log 14 over 7, that is 2, base 2. That means our answer here is what? 1. As we have proved earlier, I want to take, I think we have taken this. I want to take the last one, which is very straightforward. That one is we can rewrite this as log 7 raised to power half as well, base 7. And which will now be half log 7 base 7. And our answer is half. I believe that one is very straightforward. And now, let's see. We need to take some logarithmic equation as well. Just like we had in the case of indices, we simplified some problems. We took some equations, and now we have simplified some problems here, and now we want to solve some equations as well. Let me treat the first equation. So further examples, we want to solve the logarithmic equation now, like we did during our indices class. If a raised to power 2 minus x is equals to t, find x. From the definition, this power, the exponent 2 minus x, now will be equals to log t to the base a. I hope this one is straightforward enough for us to interpret from the definition that we have established earlier. And now, we can, since we are looking for the value of x, don't forget, we will be removing everything that is attached to the variable. 2 is attached, we want to remove it. So we are taking our x to the other side of the equation and bringing log into this. So we have 2 minus log t base a now equals to x. And therefore, from here, we can have, because I want to simplify this one further, to get the value of x, because my x is actually this. Then I want to simplify further. How? If I multiply this guy by log a base a, log a base a is 1. So I'm just multiplying it by 1. That implies that we can have 2 log a base a minus log t base a. Don't forget, from our third law, I think we have been making use of that third law every time. And this will be log a square base a minus log t base a. This is x, this is x. Now, since their bases are the same, we can perform operation. That minus there will just interpret division, and that will give us, this one will give us, this one here will give us log a square divided by t is a equals to x, which is the required solution. We just simplify further to have that. Now let's take one or two more logarithmic equations and solve. Another question that I would like us to look at here is given as good. We have log x plus 1 base 2 plus log x minus 1 base 2, all of this equals to 3. What do we do here? We know that addition is multiplication. Okay? But we needed to make this guy look like all of them. Because he is alone. He is feeling lonely. We want to relate them so that they can become one family. How do we establish that? This is log x plus 1 plus log x minus 1. There are two bases 2. If I multiply these 3 by log 2 base 2, I don't think I've done any harm because this is just 1. This guy here is equals to 1. It has not changed anything. That's beautiful 1. In mathematics, we have beautiful 1, we have beautiful zeros. Here is 1. Okay? Now, I can perform operation because all of them now look alike. For this guy here, I have log x plus 1 multiplied by x minus 1 to base 2 now equals to log 2 cubed from our third law, base 2. You see, log base 2, log base 2. I can delete that. That one takes care of itself, straightforward. And I'm left with what? X plus 1, x minus 1 equals to 2 raised to the power 3, which is 8. So, since we have this now, we can just expand this. X by x, we have x squared, x by minus 1 minus x, 1 by x, we have x, 1 by minus 1, we have minus 1, 2 raised to the power 3, which is equals to 8. And therefore, this guy here will give us x squared minus 1, since this will go, equals to 8. That implies that our x squared here is equals to 9. If this one comes here, it becomes addition. So that will be 8 plus 1, which is equals to 9. And therefore, our x is equals to plus or minus 3. If we take the square root of 9, we have this. So, that will be our solution. Very straightforward and short. I want to take one more before we wrap it up on this. This one says, find the value of A if log, we want to make use of the transformational law here, A base 3 plus log 3 base A equals to 2. The first assignment you want to do here is to change this so that we can have equal bases. So we can say our equation star can be written as log A base 3 plus 1 all over log A base 3 from our change of base law. This is equals to 2. So if we let x be equals to log A base 3, this implies that we have, let's call this equation star star. This implies that equation star star becomes x plus 1 all over x equals to 2. And if because of this fraction, this thing is giving me headache, I want to remove it. So, because of that, I can multiply all this equation through by x. I can call this guy star star star. So that by the time I multiply this by x, I have x squared plus 1 equals to 2x. And therefore, I can write this equation as x squared minus 2x plus 1 equals to 0. This looks quadratic already. So to solve this quadratic equation, we look for two factors of minus 2. That when we multiply, we have 1. When we have minus 2. And that will be minus 1 and minus 1. So x squared minus x plus 1 is equals to 0. We substitute that one for minus 2x. And within these two, now if we factor x, we are left with x here, we are left with 1 here. If we only 1 is common here, minus 1, this is, we are left with x here, minus 1 here, equals to 0. And therefore, we can see that x minus 1 is common. And we are left with x here, we are left with minus 1 here, all of this equals to 0. So x minus 1 equals to 0 implies that this is equals to 0 or x minus 1 equals to 0. Because when you have two things multiplying each other and we have 0, it implies that either of the two is equals to 0. Therefore, our x is equals to 1 twice. In quadratic equation, we call this repeated roots. So, since we have represented our log A base 3 as x, therefore, log A base 3 is equals to 1. And initially, if we are writing this in its initial form, we have A equals to 3 raised to power 1. And therefore, our answer here, this implies that our A is equals to 3. This implies that A is equals to 3. And if we are putting this back, we want to substitute this back into the given question, which is log A base 3 plus log 3 base A equals to 2. Immediately we put our A, the value of A back here, we have log 3 base 3 plus log 3 base 3. This one is 1 plus 1, which is 2. That shows that our solution is correct. Please, you can go through this again on your own leisure time. And if you have any concern, any question whatsoever, go to the comment section, put your question in there, and we'll attend to them appropriately. Thank you. I want to check if we can get some questions for you so you can practice at your own leisure. Let me check. Ranging from the logarithmic equations and some questions that we can simplify. Don't forget, please, let me quickly mention this. Logarithm, we have it in two forms. Here is one part that we have treated. The other one is the common logarithm, the one we have treated during our elementary, during our basic classes, where we have log and anti-log. We have treated addition and multiplication, how addition is related to multiplication there, and how subtraction is related to division as well. So we can go and treat all those ones, but as far as this class is concerned, this is the area we want to touch, the logarithmic equations. I want to pick a few questions here. Please test yourself with these two questions. And let's see what we have. If you have any concern, don't forget, feel free to send your questions via the comment section. And you can be rest assured that it will be treated accordingly. Thank you.